Hi everyone, welcome. So my talk is called Let's Make a Pact, Don't Break My API. So I generally like to start this with a little bit of an icebreaker, kind of difficult in a virtual situation, but I'd just like you to reflect and see if you've ever been in a situation where you have broken an API for one of your consumers. And I definitely fall into that category. I've done that on numerous occasions. And maybe on the flip side of that situation, have you ever had a case where you've built out a client, you're depending on one or multiple APIs, and suddenly an API that you depend on stops working or starts behaving differently, and you've received no communication from the API provider? Again, I've felt that pain more than once. So what I'm going to talk about today is really how to address that challenge. So how can we promote features through our APIs and evolve our APIs safely? And we'll look at the relationship between the provider and the consumer and the expectations that exist on both sides in the modern API landscape. So a little bit about me. My name is Frank Kilcommins. I'm an API technical evangelist at SmartBear. I'm a software engineer and software architect by trade, and I'm very passionate about APIs and the developer experience surrounding APIs. And to explore the challenges that I've laid out at the start, what I'll aim to do is just take a brief look at what's happening across the API landscape and why things are probably going to get harder for all of us. And we'll look at then how can you design for future feature promotion through your APIs and how you can do that safely. We'll maybe critically look at extensibility, so good extensibility patterns, and can you succeed with extensibility alone? And probably the TLDR hint here is that you probably can't. So I'll introduce the concept of bidirectional contract testing, and we'll explore how that can help us safely evolve APIs. I'll run through a demo showcasing how you can get started, what it's all about, and then hopefully you'll be able to leave the conference and leave this talk with some takeaways and a good understanding around bidirectional contract testing. So microservices are everywhere, of course. I think for most of us that have been involved or are involved in APIs or just general web development, we've seen the exponential growth of microservices and APIs over the last number of years. And, we can look at all of the industry reports that come out, the ones that we produce ourselves at SmartBear, as well as those by our peers across the industry, like over at Postman. And we see that microservices are indeed identified as being the main catalyst for the continued growth across the API landscape. They're really more than just a fad. So for any of you that might follow industry analysts like Gartner, you might be familiar with hype cycles, and microservices really have left the threat of disillusionment. So we're seeing this continued shift within the most and the majority of organizations from monolithic architectures to more consumable and capability focused architectures. And that's where microservices are, of course, very well suited. They help us unlock the value and the capabilities that's potentially hidden away within internal systems. So there's more and more of them being created. And managing that increasing number of APIs and microservices is getting harder, and it's something that's often referred to as API sprawl. Now, to deal with it up until this point in time, most of us have relied on traditional API management approaches to perform important activities, from acting as a central catalog for our APIs to improve discoverability, even enforcing base levels of assurance on the API. So the minimum amount of security that must be honored in order for the gateway to be able to process and pass through that API request. Also acting as a hub for documentation, and maybe even most importantly, acting as that matrix where we can go to understand what consumers are consuming and relying on what APIs, and having also that place where we can go, or that standard process for authorizing permissions towards APIs and services themselves. And if you're not experiencing any problem with API management as you stand today, then the chances are that you probably will in the near to midterm future. So more microservices will be created within your organization. And if we look at what Gartner are saying, they're saying the chances are as much as 50% of microservices will not be managed by traditional API management tooling by the year 2025. So that means there's a high risk that they will become zombie APIs, ones that are potentially poorly maintained, susceptible to security vulnerabilities, and more shadow APIs will pop up because we'll lose track of what APIs are there. So we'll reinvent the wheel within our organizations. The cognitive load, unfortunately, for keeping track of all of this will fall upon the teams, and it can be very, very easy to lose track quite quickly. And losing track and not being aware of who's consuming your APIs can in fact cause a blindness, and that has several implications. And the one I'm going to focus on in this talk today is that it's going to make the safe evolution of your APIs much more difficult. Now, one of the fundamental ways that we do our best, to not break APIs and to introduce new changes and new features through APIs is to have strong design practices. Design first as an approach for microservices and APIs ensures kind of thoughtful and let's say well-defined and agreed design before we go and implement anything. And the earlier you can bake extensibility as a practice into your API delivery machine, the more likely it is that you will have long-living APIs. And longevity is, it's a good indicator, it's a good trait of a successful API. And here's kind of a little cheat sheet for API extensibility. And the first one is, think about APIs from the outside in. So think about the consumer experience and what the consumer needs, and make sure that the API that you're delivering is solving that consumer problem. Use specifications, so ones like OpenAPI, to describe the surface area, and focus on good documentation to allow the consuming developer to ramp up as quickly as possible. Effectively treating them like a product insofar as that you're prioritizing discoverability, usefulness, and usability as attributes that will really aid and promote the adoption of your APIs and make it easier for them to be used and reused, because APIs that exist and are not consumed are absolutely useless. Moving more onto the tactile side of kind of things that I would recommend to do, what you need to do is define your extension points. And what I mean by that is that you will advertise to your consumers what parts of the API are stable versus what parts are maybe newer, maybe MVP, and they're more susceptible to change in the near term. So don't be afraid to communicate that upfront with your consumers. It can really go a long way to set the expectations. Then communicate also a extensibility pattern. So by that I mean you should inform your consumers the rules that you would like them to follow if they encounter something new that they haven't seen before. And must ignore is probably the most common extensibility pattern out there. So that means that you want your clients to be tolerant. So you're informing them to say, if you encounter something that you do not understand, then you must ignore it. Your client implementation must not break just because you do not understand something new. And then we'll do our work on the provider side to make sure that anything that we introduce is safe and it's a backwards compatible change, and it will not materially impact the functionality of what was there in the previous minor version. And then when I get onto that concept of minor versions, I think having a well-defined and clearly communicated versioning strategy is good practice, and it's almost a base expectation on a consumer side. And semantic versioning is probably the most well-known out there, and that sets again a clear expectation as to how you deal with patches, how you deal with minor backwards compatibility changes, and then how you also will deal with a breaking change if in fact you have to make a breaking change to your API. Testing for extensibility is great. Can you then even make it possible for your clients to peek ahead and test their client implementations to see if they're going to work with the next version of the API that you're about to roll out? And above all, communicate. So for each one of these points, communicate. Every time you make a change to your API, make sure you have a change log. Use that change log as a way to connect again with your consumers, to pitch the value of the new features that you're adding, and create that sense of FOMO on their side and really pull them along with you throughout your API journey. On the don't side, most of these are very self-explanatory, but don't add required inputs to the API because that would be a breaking change, of course. Don't remove outputs or make them optional. Don't change the type of a property. So if you have a string today, make sure it's not an int tomorrow. And then jumping to the last one, don't be inconsistent in your process. So every single time you're going through even a patch fix, a bug fix, or a new feature enhancement to your API, follow a consistent process every single time. So if you do this, if you bake good extensibility hygiene into your API practices, if you're really thoughtful around the evolvability attributes, are you going to be successful? Well, unfortunately, probably not. So extensibility alone will not guarantee success. You can only achieve so much with interface design, no matter how good it is. And even with really solid extensibility techniques, the chances are that you will, in some shape or form, break the expectations on a client side. And API design in general is a skill that's probably lacking to a certain degree within the landscape or within the API space. And that's showing up in some of the industry surveys that are out there as well. So there's a lack of good API designers in the market, which means it's more difficult for us to achieve high levels of good extensibility design. That doesn't mean that you shouldn't follow kind of the cheat sheet or the best practices with regards to extensibility. You absolutely should, because of course, good extensibility, good design hygiene allow us to hope for the best for a decent period of time. But with the acceleration of microservices growth across the landscape, we also need to be able to prepare for the worst. And we need to be aware of what's known as Hiram's Law. And Hiram's Law is, and I'll paraphrase, it's with a sufficient number of users of your API, it doesn't really matter what you promise in that interface design contract. All observable behavior of your system will be depended on by somebody, and that absolutely happens. So you will have some maybe undocumented behavior within your API that will be understood by consumers, and they'll expect that will continue to behave like that. And if that potentially was unintended and you then address that potentially could be a breaking change for someone, even though from a provider perspective, you've never advertised that the API was meant to behave in that particular way. And the fear of this can paralyze many providers. And we have a problem in the industry with major version proliferation. So as we lose track of who's consuming an API, what their explicit expectations are, it can really cause a little bit of a paralyzing effect on the API provider side. And then there's a knee-jerk reaction, of course, to create a major version of your API, which basically is saying, hey, we're not sure if this change is breaking or not. So to be safe, we'll create another version to make sure that any clients that are still connected to the previous version will remain up and running. And having multiple but yet different versions of the same API incurs real costs on the team. It incurs cognitive costs with regards to be able to manage these things, but it also causes actual real costs for teams. So it's important to kind of bear that in mind. So major version proliferation is a cost problem also for organizations. And that cost can be felt also on the testing side of let's say the IT teams and the API teams. So zooming in on testing for a moment, I think it's worth noting that if you're also employing the same testing strategy as you're maybe moving from a monolithic architecture over towards a microservices architecture, then probably you will not be successful. So delivering new value with the appropriate return on investment will be something that's hard to achieve. And what's depicted here is a very simplistic picture. So we have a consumer component, and that is connecting and relying with an underlying microservice called microservice 1. And if I was to continue to employ, for example, an end-to-end testing strategy, which I was quite comfortable with in a monolithic architectural approach, and apply this to this specific setup, which is depicted here, then every time I would want to make a small change to the consumer, I would have to stand up all of the underlying components in order to be able to execute those end-to-end tests. And I would also need to be able to manage all of the contextual data to allow those tests to run effectively. And that is a very costly exercise, and it leads to what I call an unbalanced testing pyramid and testing approach. So if we're over relying on integration testing and end-to-end testing, the testing pyramid is not really in its optimal setup, especially for microservices. So it's expensive to set up and maintain all of the underlying components and infrastructure. It's also slow to get feedback. So you might be waiting for 30 minutes, even more, for that pipeline to run in order to get the feedback that you want, it's unreliable. So managing all of that context and that data can lead to us ignoring failures. So have any of you ever been in the situation where you make changes, you run the tests, a test fails? You weren't really expecting that test to fail because it's not relating to the change that you made. You run it again, it passes. So then you're saying, yes, great, we can proceed. So what that actually means is that you've lost all confidence in the ability for your tests to be relied upon. So you really have an unreliable and expensive approach. And you also have an approach that's not very targeted. So it's difficult to just test explicitly what you're changing. You really have to stand up a complex underlying environment, and you can spend a lot of time investigating false positives. And this brings us then on to dependency management for microservices. So how can you manage the dependencies between all of the provider components, all of the consumer components, and manage those across the different environments? It can become quite a headache. So what I have here is a very simplified CI setup. So it's 2 CI pipelines. So this is just for example purposes. So 2 CIs across 3 environments: the CI environment, the staging environment, and a production environment. So when I say CI, think of continuous integration, so GitHub Actions, Azure DevOps pipelines, Jenkins, and so forth. So anytime someone commits a change, this process will be kicked off. And here, what we could expect is that, once all checks and balances are passed, we will be able to safely promote changes towards production. So you will see that I have different versions of consumers, different versions of providers between CI and production. So we're in the process of deploying some features and some enhancements towards production, and we're going through the process. Now, what we might expect is that, at each point within these environments, we'd make sure that the version of the consumer conforms to the contract or the expectations with respect to the provider on the same environment. So for example, if we were to run tests on the CI environment, we would expect to say that consumer v3 works well and is compatible with provider v3 if those tests pass. And then if other tests pass, maybe they're security tests, performance tests, whatever the case may be, then maybe we have enough to satisfy the gate requirements in order to be able to move and promote towards the staging environment. However, one of the aspects of microservices, and of course componentization in general, is that we don't want to have to promote all components at the same time. So for instance, if I just wanted to promote consumer v3 in this case towards staging without promoting the provider v3 towards staging, what else would I need to check? Well, we'd also need to check, of course, that the consumer v3 works with the version of the provider which is in staging, which is provider v2. And then equally, if we wanted to promote consumer v2 from staging towards production, we'd also have to make sure that that version of the consumer is compatible with the version of the provider that's already promoted or deployed towards production. And what if the inverse was the case? What if we wanted to promote the provider without promoting the consumer? Well, then, of course, we'd have to make sure that the provider v3 and CI is compatible with consumer v2 and staging, provider v2 and staging is compatible with consumer v1 in production, and so on and so forth. So you can see how quickly the complexity can be increased. And then if you multiply this by more environments, by many more components, you will get to a situation that can be very difficult to manage. And one of the things that we really want to do is make sure that we still can keep the flexibility to allow us to promote hotfixes, bug fixes, and feature extensions without having to promote all components and all of the dependencies in lockstep. And this is, of course, one of the main areas that contract testing and bidirectional contract testing as an approach can come in to help. And that's what I'm going to jump into now. But first, let me just plant something in your mind. And it's a quote from my colleague Beth Scurry, who's one of the founders of Pact and Pactflow. And she says, if you can't deploy services independently, then you don't have microservices. And not alone that, you have a very costly approach to asserting quality and testing your implementations, and you have what we call a distributed monolith. And just in case the red text isn't kind of advertising it enough for you, that is a bad thing. And it removes the benefits that are promised by having an ecosystem of independent, verifiable, and deployable microservices. So bidirectional contract testing. So this is an approach that can really allow us to be able to safely evolve. And it's one that also rewards an investment in a design-first approach towards microservices and APIs. And it can help us avoid many of the pitfalls that we have discussed up until now. And if you're coming at this from let's say a familiarity with Pact or even maybe consumer-driven contract testing, then this workflow is a little bit different. So it's schema-based rather than a specification by example. As I mentioned, it really supports a design-first provider workflow, so it's well suited to starting on the provider side. And it can be described as an ability to upgrade your existing tools and processes into a powerful contract testing solution without having to throw away investments that you've already made in your technical stack. So you can already leverage open API definitions, for example, for describing your API contracts. On the consumer side, you can leverage your mocking tools like Cypress, like WireMock, etc. And then to prove out that your API implementation matches that open API definition, you can leverage tools like Ready API, Dread, Rest Assured, Postman, and so on and so forth. I would also say it's a more inclusive way of contract testing, whereas consumer-driven contract testing really requires and mandates that you have access to the code because it fits more closely in with unit testing. But bidirectional contract testing does not need direct access to the code, so it can support a wider demographic of contract testers. And when I refer to a pact in terms of contract testing, it means the artifact that is acting as the verifiable contract between a provider component and a consumer component. So I do not mean something like an open API definition, which describes the entire surface area of an API. So what it does is by capturing the interaction expectations between the software component pairs, so just one integration at a time, we have an ability to independently verify the expectations. So this can happen on each side of a single integration. So we can disregard downstream dependencies and upstream dependencies, and we can just focus on one integration at a time. So we don't have to stand up a complex environment for end-to-end testing. And the challenge, of course, that you might have experienced with certain mocking approaches or test doubles is you get stale assumptions quite quickly. And here your assumptions are kept in sync. So with the case of bidirectional contract testing, the assumptions of the consumer will be validated to ensure that they are a subset of what the provider supports. And this is really good, and you might be familiar maybe with Joe Wallens, who's quite a famous tester, and he always advocates for don't mock what you don't own, because you will get drift quite quickly on those assumptions. And the verification here with bidirectional contract testing can happen asynchronously. So one side does not need the other side to be available in order to verify. Once the comparisons on both sides happen, then you can be confident that when these components communicate in real life, that all should be fine. And what I show here on the right-hand side is an example of a Pact JSON file. So it stores who the consumer is, who the provider is, the interactions that are expected between the consumer and the provider, and then some additional metadata. So you will also see some reference here to a Pact specification. So there is a defined specification for describing the format and the structure of what should be contained within a Pact JSON file. So how does all of this really work? Well, let's run through kind of an example here. So again, it starts on the provider side. Now, theoretically, it can start on both sides, hence the name bidirectional, but it's well suited to starting on the provider side. So you can bring your API definition, like an open API definition. Once you can prove that the implementation of that API is matching what's specified on the 10, so to say, so you can bring your own provider tool to do that. Once you have those two things, you can publish that contract into the Pact Flow broker. Then on the consumer side, you can continue to unit test as you will. You can bring your own mocking tool for testing. Of course, you can use Pact DSL, but you're not mandated to. Once you serialize those unit tests or those expectations into a Pact file, you can then present those to the broker. And once the broker has both sides of that, then the contract comparison or the cross-contract verification is performed by the Can I Deploy tool, which is part of Pact and Pact Flow. And we use this feature really to control and gate a release. So it ensures that what we're deploying is compatible with any integrations or any applications that depend on this component in the environment that we're targeting for the deployment. And zooming in on this Can I Deploy check, how it makes that kind of gated decision is it uses what we call the matrix of information. So it queries all versions of the API consumer, all versions of the API provider, all integrations between all versions, which ones are compatible with each other, and then which environments they've been deployed to. So in a past life, you might have relied on heavy processes to keep track of this information. Maybe we've even had dedicated teams for this, like configuration management or even change advisory boards. Now this is available instantaneous for you. So let's run through kind of a demo. So this would take too long with the actual pipeline, so I took some screenshots to speed it up a little bit. But what I've created is a provider API. It's written in .NET, and we have a products API, which is just exposing some endpoints to allow us to retrieve some product information. I'm bringing my own functional testing tools, schema thesis, to test that what I've implemented matches what I've designed. On the consumer side of just a simple console .NET Core app. And I'm going to again bring my own unit testing tool and mocking tool, in this case WireMock, and I'm going to set the expectations. We're going to have some pipelines to publish my artifacts, and both consumer pipeline and provider pipeline will determine if it's safe to make any of these changes independently. So here's my API definition. So it's an open API document, products API, 3 endpoints, get products by ID, and then also an endpoint to delete products. So that's my design. Then once I implemented the code, I ran some functional tests through schema thesis to prove that my implementation is indeed matching what's described in the design. Once that's passed, I can commit my code and then I can run my provider pipeline. So here's me running through just a GitHub action, and then I'm leveraging the Can I Deploy check through the GitHub action for Can I Deploy to verify if it's safe for me to do this. This passes, of course. This is expected because it's the first time through the process. I don't have any consumer yet, so I'm not expecting to break any pact, any contract. So this gets published into Pact Flow. This is just an example of what it looks like in Pact Flow. So we have 3 question marks for the consumer because we don't have one yet. We have the provider contract, and you can see also within Pact Flow a representation of the Open API definition as well. Jumping to the consumer side then, I have my simple consumer app, and then I create my unit tests to verify the expectations. So again, nothing special here. I'm using XUnit for unit testing, standard setup, and a range, an act, and an assert. I'm taking advantage here of the fact that WireMock as a mocking tool has an actual integration with Pact. So I'm leveraging that component, and I'm serializing the expectations here into a Pact file. What gets serialized into a Pact file is the name of the consumer. It's all of the interaction expectations. So in this case, I'm expecting to be able to call the products by ID endpoint with a fictitious ID. And if that happens, I'm expecting the provider to return HTTP 404 not found. And at the bottom, you can see the name of the provider that I'm expecting to be able to honor this for me. Again, here's a separate pipeline for the consumer. First time through the process, everything goes good. What I'm expecting and what I'm mandating from the provider is indeed a valid subset of the Open API definition. And here now we can see that the Pact broker has been updated and everything is good. The consumer contracts and all of the assertions there are successful. Now what's going to happen is I'm going to make what would be regarded as a breaking change. So the product owner is going to come to me and say, Frank, great job in deploying that API, but I see you have a delete endpoint there, and that really only should be for the admin API and not for the API that we're exposing towards external clients. So can you remove that endpoint? Now for me, that's a breaking change. I shouldn't be able to do that. I should version an API. But what Pact flow and bidirectional contract testing allows me to do is it allows me to make that change safely, because I can fully understand and I have full visibility into how the consumer is expecting my API to provide for them. So what their expectations are. And I know that they are not using the delete endpoint. So therefore it's safe for me to make what would traditionally be a breaking change. And you can see that the pact within the pact broker between the provider and the consumer is still there. It's still valid, but you can see that the provider contract itself has updated, and now it only has the 2 get endpoints. Now it's all well and good seeing all green, but what would happen if I was to try to make a change that would actually break my consumer client implementation? So here's another example of this. So the product owner has now asked me to make some changes because client errors 404 are hindering his reports and making him look bad. So he's asked me, hey, can I change those 404s maybe into something different? I'm not going to debate it too much with him. What I'm going to do is check, is this actually going to be a breaking change? And what I can do is make that change and instantaneously see that it would break the expectations on the consumer side, because they are expecting a 404 to be returned. And if I try to change that, I will get notified that I cannot deploy this, and it will prevent me from making this breaking change for the consumer. I'll see that in the CI process, and then I'll also see it in Pact flow itself, and I can see that the contract comparison has failed, and I see explicitly why it's failed. So the provider code no longer returns a 404, and that is expected by the consumer. So I get explicit information into that, and the matrix of information that's continuously queried by the can I deploy check is also updated. And here we can see the top one has failed, and we can see that the environment is NA. So I was not allowed to deploy that change into production. So hopefully you'll see that by introducing a technique like bidirectional contract testing towards your microservices approach, it can reduce your need for end-to-end testing and integration testing, and it can significantly rebalance your costs with regards to testing, and enables you to really safely evolve microservices. You'll have an approach that's simpler, it's cheaper, it's faster, it scales linearly as your number of microservices scale, and it allows you to make sure that you can keep that flexibility and deploy independently. And with regards to how this benefits a design first approach, one of the main challenges that we have with API design first is that you lose visibility quite quickly once you get an API into production and you start ramping up your number of consumers. And it can be really hard to make informed decisions around what changes will be breaking, what changes will not be breaking. All you can do is assume that the full surface area of your API definition is depended on by somebody. But with contract testing, it gives you that full explicit insight into how consumers are consuming your API, and it lets you have a more pragmatic rather than dogmatic approach to your API versioning strategy. So hopefully you see the benefits. Hopefully you enjoyed my talk. Thanks very much for attending. If you want to connect and reach out, please do. Here are my details, and here's how you can get up and start playing with contract testing, and also some useful resources that helps me frame some of this talk. Thank you very much.